everybody. Sujoy will be taking your math session right now. Another hour of really interesting tips, tricks, and concepts in quant. The last session was great. I personally attended it, and there were a few things which I thought I knew, but I figured that I didn't. So over to you, Sujoy. Everybody have fun.
So I'll be taking your quant session now. So what I have rather planned out is like I'll be looking at a few select questions across all subjects, like across all the topics that we have. Okay, some on number properties, some on inequalities, then coordinate geometry, a couple of them. Okay, averages and stuff. Okay, a couple on geometry also. So we'll look at all of these, and we'll discuss some associated concepts also. So it's not going to be only solving questions and then I'll tell you the solution and it's done. No, so I'll also discuss a couple of associated concepts so that it will help you to understand how this, whatever we are doing, how this has come about. So without like discussing much, let's start with the questions one by one. Okay, so I just be writing down on the whiteboard. Okay, so the first question is on numbers, and it goes like this. So you have a line of unit length, and you divide this line. So basically it's a number line with 0 and 1 marked. Okay, so 0, 1, 2 like that. So I have just taken that portion which is 0, 1. Okay, so you divide it into sevens. So 1 over 7, 2 over 7 like that. Basically 7 equal parts, right? So 7 parts. And also divide that same line into 5 equal parts. 7 equal parts and 5 equal parts. What is the, note that this is a number line, so where every point has a value. Okay, so like for example this value would be half, right? Something like that. Okay, so what is the smallest gap between any two of the above markings? Okay, and I can give you answer choices obviously. Okay, okay, all right, so let me ask you, those who have answered this, for example, Sharmi, you are the last one to answer. What was your thought? How did you think about this question? Did you just do 1/7 and 1/5 and took the difference? Simply performed 1/5 minus 1/7. Why? What made you think that 1/5 minus 1/7 will give you the least gap? Because both of them are the least. That's why. Can't it be possible that two in between numbers, like those fractions in between, are actually closer than how close 1/5 and 1/7 are? There is a possibility, right? Yes, so there is a possibility, but the problem is the possibility is very difficult to check. So if you have divided into sevenths and then divided into fifths, so basically what you have are values like 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, then 7/7 is 1, right? And the fifths are 1/5, 2/5, 3/5, 4/5, 5/5 is 1. Now, who's going to go on and check whether 3/7 minus 2/5 is how much? 4/5 minus 1/5 is 4/7 is how much? Yes, exactly. Not a very good strategy, right? So what we do is, yes, those who have got 1 by 35, you must have done this. That's a good thing that you have done. Bhavya, you have done it. And I think someone else had also got a 1 by 35 in the beginning. I'm forgetting the name. Oh, Bhavya only you had got. Okay, fine. So you divide this line as if this is 35. Okay, you don't think of it 0 to 1. Okay, take it on a scale of 0 to 35. Okay, because why 35? 7 parts and 5 parts. So now when you divide it in 7 parts, your values are going to be, so 1/7 of 35 means like 5. So your markings will come at these values 0, 5, then 5 more, and like this, right? And the end. And when you divide it in fifths, that means 1/5, 2/5, so on, your values or markings will come at, let's use a different thing, 0, 7, 14, 21, 28, and 35. It's very easy to spot this or this has a gap 1. Isn't it? It's very easy now spotting it that there is a gap 1. So when the length is 35, the lowest gap is 1. So when the length becomes 1, you scale it down, it must be 1 by 35. That's your answer. So it is not about subtracting fractions, but magnifying it, make it bigger. Instead of thinking of 1, you think of 35. Then find out the gaps and then scale it down back to what the question was. This thing that we did, taking a multiple of 5 and 7, is a very useful strategy. Okay, in a lot of areas, in arithmetic also, in percentages, ratios, a lot of other cases, you will find that doing this makes your calculation way faster. Okay, let's take another question. I hope everyone is okay with this. Good. Any doubts? Then just feel free to message me. Okay, chalo, let's move on to the next one. So you have x as a positive odd integer. This is an easy question. Okay, so x is a positive odd integer. You have to compare two quantities. Okay, quantity A is basically -3 to the power x, and quantity B is negative of 2 to the power 2x. You have to tell me which of the two quantities, A or B, is the, like, A is bigger or B is bigger, or they are equal, or there is no relationship between them. That means the inequality cannot be decided. Yes. So good. Everyone has more or less answered A. Most of you have answered A. What happened to Bhavya? You said B. You got the last one right. This one you got wrong. Not D. Not D, Prince. It will be A. You can just see, take a number. Okay. In these cases, if you want to analyze and do it, it's fine. But you can just take a couple of samples and then verify the result as well. Say take x as 1. Why do we take 1? A positive number which is also odd. So you can take 1 and 3. If it is 1, then what's quantity A? What's quantity B? Who's bigger? A is bigger. -3 is a smaller negative, right? Hence is closer to 0. If you take 3, then quantity A is -3 cube. So that's -27. Whereas this becomes negative of 2 to the power 6. 2 to the power 6 is 64. So that's -64. A bigger negative. A is consistently coming out to be smaller negatives and B is coming out to be bigger negatives. Okay, A is the one which is greater in this case. You can easily analyze this and also answer. This is simply negative. See, x is odd. So this -3, I can think of it as -1 to the power an odd number multiplied with 3 to the power that odd number, which will be -1 to the power odd is negative times. So it's a negative number, 3 to the power odd. This one, the minus is already outside. You don't have to do anything. And 2 squared is basically 4 to the power the same odd number. So it is obviously now 3 to the power odd is a smaller negative. This is a larger magnitude negative. Obviously, A is the one which is the answer. Okay. Here, if I had not mentioned this, then the answer becomes D. Because then you can start plugging in even numbers also. Okay. In that case, A will become positive because X becomes even, negative is inside, will become positive, B will remain negative because the minus is outside. So A becomes, no, in that case also A is bigger. Sorry, we said A is bigger, right? Yeah. So it doesn't really matter though. Okay. So the answer to this question is A. All right. Moving on to the next one. So everyone is fine with this? Why it is A? I hope this was pretty straightforward. An easy question. Next one. Let's take a one on coordinate geometry. Okay. So there are 2 points. So point, let's say A, whose coordinates are PQ, and B, whose coordinates are RS. So the question is, you have to compare the quantities, quantity A and quantity B. Quantity A is distance of A from the origin, and quantity B is distance of B from the origin. Now obviously something else is also given. So it's given that P is R plus 1. So P is R plus 1. Q is S minus 1. And S minus R is equal to 1. So this is given to you along with this. So you have to compare the two quantities, distance. I hope all of you know what is the formula for the distance between 2 points, right? In case you are not, let me just quickly mention that. So if you have 2 points, x1, y1 and x2, y2, then the distance between them is given by the square root of difference of the x's squared plus difference of the y's squared and added. This is the formula for distance between 2 points. It's basically just coordinates in Pythagoras theorem in a way. So I'll give you 2 minutes. This one is a tough question. Yeah, a lot of you have answered right correctly. What was your approach? Choosing numbers. Good. Okay. What sort of numbers did you pick? Yeah, start with R and S because everything depends on R and S. As you can see, the value of P depends on R. Exactly. Yes. Very good. The value of Q depends on S, and R and S are dependent on each other based on this relationship. So you can just plug in S to be, let's say, 2, R to be 1, the smallest numbers. Okay. In that case, S is 2, then Q becomes 2 minus 1. So Q becomes 1. And P is R plus 1. So P becomes 2. So clearly, as you can see, that PQ is 2, 1. And RS is basically the reverse 1, 2. Basically, they have just swapped positions in a way. Yeah, exactly. They have just swapped places in a way. Once you realize that this is going to remain the trend every time, you can just safely go ahead and answer this. You should not be wasting your time in doing all this. Okay, what's the distance from this? Okay, so P squared plus Q squared. Then here the distance, okay, sorry, yeah, R squared plus S squared. Then plug in what is R in terms of P, and then plug in S in terms of Q, then trying to relate using this. By the time you would have done all that, someone else would have already completed 3 more questions. Yes. So before you start doing, see, this is not asking you about an expression for the distance, right? That is what you have to understand. If you had asked for the expression of the distance, then I still understand that, okay, you tried the long approach by plugging in, I mean, using the expression directly. But you just have to compare. Once you start plugging in the numbers, you get a fair amount of idea that this is what is going to happen. If you are not convinced, fine, you pick another set of numbers, 4 and 3, and you redo that process, you will find the same thing happening again. So once you are now convinced, after 2 times, you should be convinced that it's going to remain the same, just move ahead. Okay. GRE hardly gives you a case where in a complicated question like this, you have plugged in one set of numbers, two set of numbers, and then you will find that, okay, somewhere later on, there will be an exception to the rule. It does not work that way. All right. So those who have got it, very good. So plugging in numbers is something which you have to do. All right. The next one. I'll be just sharing a screen for this. Okay. It's a geometry question. And I just want to see how you think about solving this. All right. So the question goes like this. Basically, you have an envelope. Basically, this is like an open envelope, right? Where you put in letters and all. So it's opened BCDF. So it's given AB equal to DE. So I'll just mark that so that it becomes easy for you. AB equal to DE, BC equal to CD, BE is parallel to CD. Okay, so these two are parallel. BC, so these two are also parallel. You have been asked to figure out this area to this area ratio. Maybe like you can say 2:1, 1:1, 3:2, whatever. Two is to 5. Okay. Someone has come up with 2:5. No, both are incorrect, unfortunately. No, not 1:2 either. Bhavya, actually, the hint is, I mean, I'll show you the method. I mean, there is nothing to actually solve here. Okay, if you are observant, you can actually do it by just breaking it down, break the figure down. Yeah, Gaurav has got it finally. 1:1 is the answer. Very good. Yeah, Gaurav, what's your approach? Chamindri, you have also got it. Very nice. 1:1. Great effort. What was your approach? Utkarsh has got it. Yeah, equal areas I understand, but how did you do it? Vedant, you also got it. 1:1. How did you do it? Any idea? I mean, you can tell me like how you can share your idea maybe. Did you try to calculate? Extend the lines. Yes, very good. The easiest way of doing this. See, you can all see that this is a parallelogram, right? I mean, there is no doubt this is a parallelogram. Opposite sides are all parallel, right? In the same way, this also would become a parallelogram again. Okay, just to get you an idea, see, just draw this. Okay, just extend it a little bit, and now you join this, just breaking it down. Okay, breaking this down as much as I can. Okay, do you realize this? These two areas or triangles are equal in area. It's very clear. I mean, in fact, all these four are equal in area. This becomes a rectangle anyways with a diagonal. So those two will also be, these two will also be equal in area. Okay, this and this become equal in area, bisecting it, because F will eventually become the midpoint. Okay, F here will eventually become the midpoint. Why? This is a parallelogram, so CD and BF are equal. This is a parallelogram, so CD and FE are equal. So obviously BF and FE are equal, and you get a F as the midpoint. And therefore, if you drop this, it will also be the bisector, okay, of that side, DE. Now, in the same manner, again, this is a rectangle. You have the diagonal equal in area. Here also rectangle, diagonal equal in area. And we just have one rectangle left, which you can just join and say that they have to be equal in area. Yeah, Bhavya, they are nothing drawn to scale. They don't have to be drawn to scale. There is no scale. I mean, there is no scale. They have not mentioned any dimensions, right? Like this is 5 units, this is 2 units, isn't it? So you don't plug in. Why will you plug in? Okay, there is no need to plug in. There is no scale involved here. Scale, when you say not drawn to scale, what does that mean? Say I have drawn a triangle where I given that this is 60 degree, this is 40 degree, and this is something. This is not drawn to scale. I mean, that means that this might not look like a 60 degree, but it is. Again, if I have a triangle where this is 6 and this is 8, then I can say that this is not drawn to scale. What does that mean? 6 and 8 do not look like they're 6 and 8. Like this is 6, then this length cannot be 8. 8 might be slightly bigger. So that is why you do not take it to scale. But in this question, there is no dimension mentioned, there is no angle mentioned, right? They have just mentioned a set of lines which are equal. So that is already looking like equal, right? They are equal. These two are looking equal. The 90 degrees are looking 90 degrees only. So anything which is not drawn to scale would be like, that would be valid only if there are dimensions given. So here there is no assumption that I'm making. I am saying that this is after all a rectangle. In the rectangle, a diagonal will divide into equal areas, right? So there is no scale involved that will, like for all rectangles this is true. However way you draw it, like you draw like this or draw like this or draw like this, if you draw a diagonal, it's going to divide into equal areas. That's it. Okay, so that is fine in this case. I hope I have been able to understand, Bhavya, make you understand that this is, there is no effect on scale in this question as such. Okay, you draw completely different forms, it's perfectly fine as long as you maintain the 90 degrees and maintain those two sides equal. So how long you, so just magnify it, it's okay. So what do you have now? Finally, the question was ABE. So where is ABE? ABE is this one. You have got 1, 2, 3, 4 triangles. BCDF is this parallelogram, 4 triangles, 1:1. Over. How can we say BCD and EFD are equal? BCD and EFD. We are not saying by looking at the shape. We are saying that BCD is made up of these two dots and EFD are also made up of these two dots, though arranged in a different way. So after all, the areas must be the same. Like for example, if this is 10, this is 10, then this will also be 10 and 10 only, right? So that way I'm saying. By looking at it, it does not look like they're equal in areas. Understood what I'm saying? After all, it's the same set of dots, right? All of these areas are the same. If this area is X, this is also X, this is also X, this is also X. This will also be X, this will also be X. After all, any parallelogram, if you join the diagonals, all these 4 triangles always have equal area. That's the basic property of a parallelogram. Does not matter how you draw. So it's a parallelogram. The diagonals, it's, in fact, this will become a rhombus because the diagonals are perpendicular. I am not getting into all that stuff. Okay. In a rhombus, what happens? All sides are equal. And the additional property that comes is that the diagonals will be perpendicular to each other. Here, because these are given 90 degrees, this and this will also become 90 degrees. So this actually ends up becoming a rhombus. That means all of these dimensions are all equal. Okay. And again, these will end up becoming equal. So this will eventually become a equilateral triangle. All of these will end up becoming equilateral triangles. Okay. These are all 30, 60, 90 triangles that you have drawn. 30, 90, 60. Why? F is center of rectangle. F is the center of the rectangle, right? This is one diagonal. This is the other diagonal. F was the midpoint, right? We already established that, no? Because this was a parallelogram. Yeah, okay, I'm explaining again. See, I said this is a parallelogram. This is a parallelogram. This length and this length are equal. So F is the midpoint. If F is the midpoint, then this must be the diagonal. This must be the diagonal. Got it? So this is the logic behind it. A lot of these questions on the GRE, which asks you about ratio of areas, actually can be solved very efficiently by breaking that stuff down into smaller parts. Okay. Let me give you one more similar type. Okay. Let me give you one more. No, Bhavya, again, going back. F is not given to be midpoint. I said, if this is a parallelogram, what is the conclusion? These two are equal. Again, these two are equal. So this becomes midpoint, right? These two are equal, no? So F is the midpoint. That's what I was saying. All right, let me give you one more. Very similar idea. So you have a square, and inside it you draw another square. Okay, a square within a square. Your question is, what is the ratio of the smaller square area to the larger square area? How fast can you get it? Let's see. Yes, good. Mehak, just think again. Prince, also, you also think, how can it be smaller to larger? How can that be your answer? Yeah, exactly. 1:2 is correct. How do you solve this? If you are thinking that, okay, let me take the length of the outer square to be 4x, okay, whatever, and stuff, and then keep on computing stuff, that's a waste of time. By the way, a lot of people, I'll tell you one thing, it's a very important or a very nice trick that you can use. If you see a question which is asking you ratio in area form, okay, like square inside a square or whatever, okay, area form, most of you always do this. Okay, let the square length be x, so this is x by 2, x by 2, and then start calculating, right? Observe, x is not important really, because if you think that x is important, then your answer would be in terms of x. then obviously the answer is cannot be determined. You will not get an answer at all if it keeps on varying with what your x is. So you have to realize that when you are asked a question like this, what is the ratio of area, and you are expected to give a numeric answer, actual length doesn't really matter. In such cases, the idea is not to take an x, but to take a well decided number which is very easy to calculate, like 4 or maybe like 2. Don't take 1, because 1 means this will be half. All that fractions start coming in, right? Things become complicated with fractions always. Take the length as 2. So 1, 1, 1, 1, 1. Doesn't really matter what you take as long as they're integers. Root 2 over root 2 times root 2. Area is 2. 2 times 2. Area is 4. Done. 1:2. Even without using any special trick or shortcut, you have done it very fast. Why? Because you have chosen your numbers well. Okay. Now coming to the method where you don't even need to do all this is just drop this and this. So what do we have? Equal, 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 equal. Okay. As a result, the outer square is 8, the inner square is 4, and it's half over. Everyone followed? So rather than whenever you see a question like this, rather than jumping into let me start with x and work it out and work it out and keep working on it, try to see whether by visual thing you can break that stuff down and see whether that can work out also. This is a nice strategy that you can use. Okay. Next. So let's move on to the next question. So you have to tell me what is the mean of yes, Jasil, very good. I'll come back to you. Let's wait for the others. Kiran, good. Yeah, good. All of you are getting them right. Very nice. I'm very happy to see that most of you are getting stuff like these correct. These are considered some of the tougher questions. All right, almost everyone has got it right. So what was your approach? What did you do? Ah, Jasil. Okay, nice, but you have a fallacy there, isn't it? Don't you see? This one also ends with the same digit, last digit. What does 1477 square end in? 9. Okay. And then 9 square ends in 1. So you are supposed to add them, you will get something ending in 0. Divide by 2. what will be the result of the units digit? It will either end in 0 or end in 5 as well, isn't it? Both are possible. Ten by 2. Oh no, that means then by fluke you got it. You got it by fluke. I wish you have your luck like this on the main test also. 10 is not right because the numbers are completely different. It's a huge number which ends in a 9, and then another is a huge number that ends in a 1. You can't just say that it's just 9 and 1, isn't it? So if you look at units digits, then you are going to get something which is a huge thing ending in 0, which you divide by 2 will either end in a 0 or end in a 5. Either way is possible. So this one, if you now check units digits, 9 minus 1 will end in 8, ruled out. 9 plus 1 ends in 0, possible. 4, 64, 4 minus 1 ends in 3, ruled out. 4 plus 1 ends in 5, possible. 9 square means 1. 1 minus 1 ends in 0 again. So by this method, you are only eliminating A and C. That's it, nothing much. So won't be a very good choice. That's why this is a tough option. I mean, tough question in that sense. So what you should have done is, there is now the only other way is actually you compute. So you say that, okay, I have my calculator, I'll use that. Okay, that you can always do, but the time that you will waste in calculating this, then computing each option and then finding out, that's a huge amount of time that's just wasted. So you have to see the pattern here. Okay, what are the numbers like? You have got an odd number, you have got another odd number just at a gap of 2. So if you have x, you have basically been given x plus 2. All right, let's compute. What is this? By 2, right? So it's x squared plus 4x plus 4 by 2. 2x squared plus 4x plus 4 divided by 2 is x squared plus 2x plus 2, which is basically x plus 1 whole squared plus 1. Till here, everyone followed? 2x squared plus 4x plus 4 divided by 2 is x squared plus 2x plus 2, which is basically x plus 1 whole squared plus 1. If x is 1477, this will basically be 1478 squared plus 1. So therefore option D. This is the best way of doing this. No, I don't really see any other approach to this question. Units method is a good approach, but then in this case, it does not work because 3 options have the same units digit. The only other approach is actual computation. Yes, one thing which you can do is you scale down. So you see that consecutive to odd numbers, you take smaller numbers. Let's say you take 1 squared and 3 squared. So what do you have? 1 plus 9, 10 by 2, 5, which is 2 squared plus 1. Okay. So you see the next number squared plus 1. Okay. By looking at the patterns of the options. Okay. Then you just verify with another one, 3 squared plus 5 squared. So how much is that? 9 plus 25. That's 34. By 2 will basically, I mean, this by 2 is there. Okay. Is 17, which is 4 squared plus 1. So basically 3 plus 1, 4 squared plus 1. Okay, you see a consistent pattern, apply that and mark. This also can be done. Okay, this also can be done. Just see everyone whether you have understood this. All right, let's do one more. Let's go to the next one. So we have, let us say 3 prime 3 All right. Okay, let me redo this question. 1 minute. Not consecutive. Very smart, Prince. One is not a prime. What is 146? What is 146? I don't know what is 146. It's a number. 73 times 2 maybe. That's all I can say. I mean, there is no other property of 146. Oh, okay. In the context, sum of the three prime numbers is 146. Okay. Yes, Jasil also good. Good answer. All right. No other answers. Okay. So I'll just tell you the trick here. This is a trick question. Okay. You are not actually going to solve for A, B, and C. Okay. There will be infinite possibilities for the others. Only one possibility for A. See, prime numbers is essentially odd. Okay. If you think of all prime numbers like 3, 5, 7, and dot, 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 they're all odd. And they have to be because 2 is a prime. If any even number were prime, then that would be divisible by 2. If that even number is prime, but you are saying it's divisible by 2, that means it cannot be prime. So there is a contradiction. So apart from 2, nothing even can ever be prime. 2 is the only even prime. Now, if you have taken all three odd primes, A, B, and C, so odd plus odd cannot be an even number. It will become an odd number. So that means out of these three primes, only two of them are odd. So you have taken two odd and one even. The only even prime that exists is 2, which is in fact the smallest prime. So obviously I have asked for A only. So the answer is 2. There cannot be anything else. So this was a trick question. I was just checking whether you know your evens and odds. But obviously the GRE will not ask you, do you know an even number and do you know an odd number? So they will disguise it in the form of a prime composite, non-prime rather question. I hope this is clear, everyone.
Thank you, Sujay. Thank you everybody for attending, and I hope you really liked the session. Do let me know on the feedback form. You can write on chat as well. I hope you really liked the session, both the sessions, the verbal and the quant session, and would really love to know your detailed feedback. Again, please go and take the quick diagnostic test, set up your dashboard, write to us if you want specific sessions, specific topics. Hopefully we will have a proper month-long boot camp covering both verbal and quant, almost all topics soon. Irrespective of that happening, we will continue doing these sessions at least twice a week. Thank you, Sujoy, for the great math session. I'm poor at math, so I can totally understand how important these quick tips and tricks are. See you guys in the next session.